Linked list is a collection of nodes. Each node has data field and address field. Address field, it has the address of its successor. The linked list can be implemented in three ways. There are three types are there. The first one, singly linked list. Second one, doubly linked list. The third one, circular linked list. So in this video, we are going to focus only on the singly linked list. So if you are going to implement the concept of singly linked list or any other linked list, first you have to focus on the structure. So in the structure concept only, we are going to implement the collection of nodes. Structure is a collection of different types of data types. So this structure accepts different types of data types. So structure having the keyword like struct. For example, struct student. Then curly brace. Structure having the member with the different types of data types. For example, int roll number. Then char name. Then float mark. So now you have to access the structure member. Either you can access it directly or through the help of structure pointer you can use. So in the structure pointer is a pointer type of variable. So all the members are accessed with the help of the structure pointer. So we can have the asterisk symbol and ptr. Likewise we can access. So in this star operator can be accessible with the help of the arrow operator. So here there is a two types of operator we are going to discuss. One is called as star operator and another one is called as arrow operator. So these two operators we are going to use in our linked list implementation. So here this asterisk operator can be accessed with the help of the dot operator, and the arrow operator is the membership operator. So this is called as a membership operator. So all the members are accessed with the help of the pointer dot and arrow mark the roll number. So likewise we can able to access the structure members. So now we are going to focus on the singly linked list. So what is the representation of singly linked list? So singly linked list means a collection of nodes are linked together is called a singly linked list. So every node has the data field and the address field. Example, the data having 10 and here the data value is called as 20 and here 30, and this field having the address of its successor. For example, the address is called as 2000. So this 2000 will be placed here and the address of the next node is called as 3000. So this 3000 will be placed in the address field, and finally further don't have any other addresses, so simply it is called null. So this is a normal representation of singly linked list. Now we are going to implement this singly linked list with various operations. The first one is called as create of. So in this method we are going to create a linked list. Before that we have to define the structure. So here I am going to define a node, and each node having the two field already I said. So here the one is called as int data and the next one is called as position star next. That means the next field. So every node has the data field and the address field. So this is the data field and this is called as the address field. So likewise the data node will be framed while you defining this structure. So you have to close the structure here and the semicolon. So this is the way we have to create the structure, and this structure having the different names, that is what we have another keyword we are going to use called as a type def. We can able to use to define the user defined data types. So here the data type is called as struct node star position, and based on this position we can able to call with the different names of the particular memory space position. Sometimes we can call this common memory space like a L, another name is we can call with the P, another name is we can call with the new node, another time we can call with the temp. So the single memory space can be called with the different types of names. Sometimes we can call with the L, and sometimes you can call like a P, then sometimes you can call new node. Likewise, we can call the same structure with the different types of names. So now we are going to focus on the create operation. In this create of method, we are going to create a list. So initially, just imagine that there is no list in this memory space. So the list is equal to null, which means that there is no L. Now, first of all, we are going to create one memory space. The memory space which is going to refer this structure. So in the structure, we already have the data field and the next field. Data is going to store the data value, and the next field is going to store the address of its successor. So first we are going to create one new node. New node is equal to, we are going to refer the structure. So we are going to convert like a pointer. Malloc is a method to allocating the memory space. Size of keyword is going to calculating the size of the structure. Struct node memory space will be calculated. For example, here the integer having 2 bytes and the pointer having 4 bytes. Totally 6 bytes memory space will be allocated, and the size of operator going to give the input to the malloc method. So now the malloc method going to allocate the memory space, and that will be converted into the structure pointer. So this is the explicit conversion. So here that type conversion will be takes place. Now the memory space is called as a pointer one. Okay. So now the new node will be created. While you defining this statement, the new node will be created. So this is called as new node. So in this new node, according to the size of structure as well as the memory architecture of structure, it contains two fields. One is called as a data field, another one is called as a next field. So the new node is created. So once new node is created, now we are going to enter the value, as well as we are going to create the name of this particular node. As of now, the node is called as a new node. Now we are going to read the value. So through the scanf, we are going to read the value percentage %d, because this is the integer data. We are going to read the value ampersand new node of data. So while we using this line, we are going to get the value for this data field. Now this is a new node. The new node having already two field. One is called as a data field. Suppose if I give 10, the new node of data will be placed the 10. And now new node of next is equal to null, which means that the next field is null. So as of now, the new node is created. This is called as new node, and the new node of data we got it through the help of the new node of data statement, and the next field is null. So new node of next is equal to null. So now as of now the new node is there, but there is no list. So now we are going to assign L is equal to new node. The statement says that this is a new node already, which having the data value is called as a 10, and the next field is null, and now this is called as L. So the new node will be converted into the L. So now the new node is transferred into the name as L, and the next one is called as a P equal to L. So this is, we can call the list is called as a position. So while we calculating the number of nodes, the first node is become the first position. So for that we are going to use another variable is called as a p. So now we are going to create one more nodes, as well as we can create many nodes. For that we are going to use the for loop. For already we created one node, so I start from 2, then I less than n. For example, if the n value is called as a 5, we can create 5 nodes. So from this for loop, I am going to create the second node. So second node also having the same memory allocation, which is comes with a new node. New node is equal to struct node star. Then malloc function is there to allocating the memory space. Malloc size of struct node. The new node is created. So once the new node is created, already we have the L, so which means that already we have in the L, which contains the value 10, and the next field is initially null, and the new node is now created. So this is called as a new node and name is called as new node. And now we are going to read the value of this new node. So here the statement says that we already know the statement, new node of next, new node of next is initially null, which means that the next field is null, and here we are going to read the value of data through the scanf statement. Scanf percentage %d, then ampersand new node of data, which means that suppose if I give the value 20, the 20 will be placed here. Okay, and the L is separately present as well as the new node is separately present. And now we are going to do one assignment. So here, according to this diagram, so here we have the node with the value of 10 initially null, and here we have the new node, the value of 20 initially null. And now we are going to join those two nodes. So here we are going to have one statement. So we already said that, so the LP is called as a L. So already we know the statement. So this is called as L, another name is called as a P. We can't be able to move the list as many places. So instead of that, we are going to call another name is called as a P. So we can able to say that now this is called as a position. So position. For that, we are going to have this assignment statement P equal to L. So now we can write one statement P of next. P of next. Whoever present at the P of next is equal to new node, which means that, so this statement says that this is the field. So this field going to have the, so this field going to have the address of its next node. So which means that, so initially the node will be looking like this. So now this next field going to have the address of its successor. So which means that the direction will be takes place. Now this address will be stored here. For example, the address is called as 2000. This 2000 will be placed here according to the statement. Once we have the statement like that, we can able to do one more assignment, P equal to new node, which means that now this is called as a P, and this P will be removed from the main node. So here the L is there and this is called as a P. In case, suppose if I want to execute or if I want to insert one more node, or else if you want to, the for loop will be executed as so many times. Here I equal to 2, I less than n, I plus plus. Already I said the n value is called as a 5. Now we are going to do the same operation. So this operation will be takes place as many times to insert so many nodes. The first one is called as struct new node. So whenever we are going to talk about the struct new node, the new memory space will be created. Initially we have the node is called as a 10 and here the 2000. Why? Because the next node is already connected and the value is called as a 20, initially null, the next field, and we have the connection and the data will be pointing like this, and this is called as a L and this is called as a P. And now if I want to create one more new node, so this is called as a new node, and here the statement says the new node of data and the new node of next equal to null, which means that, so here the new node of data is equal to 30, initially the next field is null, and now we have the statement says that p of next equal to new node, which means that here we have make one connection between the next field as well as the new node. So now the new node address will be stored in the place of p of next. So in the p of next is initially null, and now that will be changed into the address field of the next node. So now imagine that this is called as a 3000, this 3000 will be placed here, and now we have another statement is called as p equal to new node. Now this p will be removed from this place and the p will be set as here. Likewise we can have so many number of nodes, every time we can able to add so many number of nodes at the end. So this is called as a creation of linked list.